Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. I hope that you have your snack and your drink of choice, water, soda, whatever you choose. I've got mine, and I'm ready to do math with you. I love spending my Wednesday nights here with you, going through some math problems. It truly is a passion of mine to help you prepare for your test so that this test does not become a barrier for you. So I love helping you. Like Dr. A said, we will be going over a variety of problems that are for a variety of assessments. So we're going to be going over pre-K, kindergarten, K through 6, GK, middle school, high school problems. But in the comment section, I'd like for you to, as we're working, ask me questions. That really helps me gauge how you guys are doing with these problems. But before we get started, I always like to start with a question and to kind of get to know you. So, where are you from? What test are you prepping for? And have you started putting Christmas decorations up yet? I know there's the group of people who wait until after Thanksgiving, and there's the group of people who put it up November 1st as soon as Halloween is over. I am definitely one of those people who puts it up as soon as Halloween is over. So, Halloween was Monday. We had Christmas trees up in our house yesterday. Now, don't get me wrong. Our entire house is not Christmased out yet. However, we definitely started on Monday. I have 2 up already. If it was up to my husband, we'd be waiting till after Thanksgiving, but I win that one. So, where are you from? What test are you prepping for? And what group are you? Are you in the ELF group where you like to have all your decorations up now? Or do you wait until after Thanksgiving? All right, I'm going to go ahead and get started. Definitely no on the Christmas lights right now. We actually don't put Christmas lights up on our house, ironically, just because of where we live. But Christmas is up. Yeah, I love it. It's good to see you, Joseph. It's good to see you, Jennifer, Hillary. Good to see you guys. All right, let's get started with our first problem. Like I said, ask me any questions that you want while I'm solving these problems. And if there's anything that you want to see me solve in the future, like there's problems that you've been working on as you're studying and you're like, man, I really wish she would have gone over a little bit more geometry. I really wish she would have gone over some problems with area of a triangle or whatever it is, let me know in the comments. That really helps me gauge kind of what direction we need to go in the upcoming weeks. So, problem number 1. We're going to go ahead and get started right out of the gate with a high school problem. What is the value of cosine of 13 pi over 6? Now, in order to solve this, you've got to know that unit circle. Now, for my people who are not taking the high school exam, don't worry, I've got plenty of problems for you too. So, what is the value of cosine of 13 pi over 6? So, if I was to draw a very quick unit circle, you need to have your unit circle memorized if you are a high school person. Now, there's a lot of different easy ways to memorize it, but you definitely need to memorize it. So the unit circle looks something like this. All this is a zoomed in version of a normal coordinate graph. Where a normal coordinate graph, it would look like this, and all I've done is zoom in on it. So that's what I've done here. Now, I know, and I've committed to memory, that the angles that we are cutting in half in each quadrant are my pi over 4 angles. So this is 1 pi over 4. This is 2 pi over 4. This is 3 pi over 4. 4 pi over 4, which is just 1. 5 pi over 4. 6 pi over 4. And then 7 pi over 4. And then this is 2 pi. Now, 13 pi over 6. The first thing I'm going to think about, is it greater than 1 or less than 1? Greater than 2 or less than 2? Because it's going to tell me what part of my unit circle we're in. So if I have 13 pi over 6, I already know that that's greater than 1 because the 13 is greater than the 6. But I also know that it is greater than 2. It's greater than 2 because 12 divided by 6 would be 2 pi because 12 divided by 2 is 2 pi. So what I've done is I've gone all the way around my circle, and then I'm getting ready to go a second time around. That's what that 13 pi over 6 means. Well, how many pi over 6s am I going past that 2 pi? Well, then at that point, we restart. So after 12 pi over 6, I'm just going to reset all over again. So 13 pi over 6 is only 1 pi over 6 more than 12 pi over 6. So that means that I'm going to be at, and if you know your unit circle, you know that each of these sections has 2 additional angles. So I know that this is my pi over 6 angle, and this is my pi over 3 angle. So I know I'm 1 pi over 6 beyond the 12 pi over 6, which puts me right here. It's the same thing as pi over 6. So what did they ask us? They asked us for the cosine value. Well, the cosine value is going to be the x coordinate of my coordinate on this unit circle. So what is this coordinate point? It's going to be square root of 3 over 2, comma 1/2. How do I know that by memory? A lot of years of studying this. But also, when I look at this, if I know that this right here is a value of 1, I'm going to go ahead and highlight it. If I know that this is 1, then I know this is 1, then I know I'm going over 1/2 about right here, which puts my pi over 3, and I did not draw this accurately, so it's not correct, but I know pi over 3 is going to be my x value of 1/2, and my y value is going to be square root of 3 over 2, whereas this one is the opposite. I went over really far at square root of 3 over 2, and then I went up 1/2. So the answer to this is going to be square root of 3 over 2. Do we have a paraprofessional math test? I'm not aware of a paraprofessional math test. Maybe I'm misunderstanding your question. So I will look into that at the end of this video and get back to you. How do you solve on each pi over 6 from the chart by dividing each? I'm not sure if I understand your question. A lot of solving these kinds of problems is just memorizing this unit circle. So part of the unit circle is knowing that most of my points are going to be square root of 3 over 2, comma 1/2, or 1/2, comma square root of 3 over 2, and then they're going to be negative and positive depending on where I'm at in the unit circle. All right. Any other questions about this? If not, we're going to move on to problem 2. All right. Below is an image of a rectangular field. If Sophia runs from W to Y to X to Z, how far did Sophia run? Let's go ahead and track that pattern because it tells us she's running from W to Y to X to Z, and then she's stopping. So she's going from W to Y, then she's going from Y to X, so W to Y, Y to X, X to Z. Those are the 3 lines that she's following. Now, that said, a lot of people are going to look at this problem, very briefly read it, because let's be honest, on these assessments, you are so pressed for time, and they're going to go, oh my gosh, they're wondering how far she ran. They must be looking for perimeter, and I know that perimeter equals the sum of all the sides, or I'm going to add all the sides up. So then people are going to go 252 plus 64, and they're going to get 316. Or they're going to know that the perimeter is all the sides, so they're going to do 252 plus 64 plus 252 plus 64 without realizing that that's not the path that Sophia took. Sophia did not go W, X, Y, Z, W. Sophia went W to Y to X to Z. She only ran 3 routes. So that said, I'm going to add my blue plus my pink plus my green, and that's going to give me the distance that she ran. Distance Sophia ran. So we know one of these distances already. We know the pink distance is 252. They labeled that for us. Now I have to solve for the blue and the pink. Now, in a rectangle, regardless of whether you would solve this kind of problem or not, you need to know that K through 12 people need to know that the rectangle has equal diagonals. A rectangle has equal sides, and then this side is going to be equal to this side, but they also have equivalent diagonals. So the diagonals are going to be the same length. So I need to solve for my diagonal. Well, if I know that this side is 64, and I know that this is a rectangular field because they told me, I know that my angles here are 90 degrees. And if my angles are 90 degrees, that means I have a right triangle here, which means that I can do the Pythagorean theorem. I can do a squared plus b squared equals c squared. How do I know that? Because Pythagorean theorem tells us that I can do the length of one leg squared plus the length of another leg squared equals the length of the hypotenuse squared. Where this is A or B, it really doesn't matter. This is A or B, it really doesn't matter. And then the blue line is going to be C. Could I also do it for the green line? Yeah. But if I find the blue line, I know that the blue line and the green line are going to be equal because those are your hypotenuses. That said, Could you have solved for green and then known that green equals blue? Yeah, you're going to get the same thing. So a squared is 264 squared plus b squared is 64 squared equals c squared. I'm going to use my handy dandy calculator. And you're going to do 264 times 264. Because if you have a 4-function calculator, you're likely not going to have the square symbol. So you're just going to know that squared means do that number that many times. So 264 times 264 equals 69,696. That's kind of a fun number. Plus 64 times 64 equals 4,096 equals c squared. I'm going to add those two numbers together in my calculator. 69,696 plus 4,096 equals 73,792. Now, what am I going to do from there? Now I have to figure out what c equals. So I'm going to square root both sides. So c equals C is approximately 271.6. So that said, when I plug that value in and I do 271 plus 271 plus 252, that gives me 794. What did I do? Oh, here's what I did wrong. You guys should have corrected me. You should have said to Amy, you did something wrong. Oh my goodness. I was like, I know that I made this problem correctly. This is not 264. This is 252. I did 264, but really it's 252. Lordy. So this, instead of all of this, let's just start over with that. 252 squared plus 64 squared equals c squared. Try that again. So 252 times 252 equals 63,504 plus 4,096 equals c squared. So square root both sides, c equals 67,600. And now when I square root both sides, c equals 260. That makes a lot more sense because now I'm actually going to get the correct answer. So that means that the blue line, which is our hypotenuse, is c. And the green line, which is also our other hypotenuse, and we know that our diagonals are equal, is also c. So I have 260 here and 260 here. And when I add all those together, I get 772. Now, if you were not allotted a 4-function calculator to be able to do that square root, here's what I would tell you. You know that the hypotenuse is the biggest side. So you know that it has to be greater than 252. So at that point, I would guess and check a reasonable answer. I would start with 255 times 255. When I did that, I would get 65,025. I would see that I'm still short a value, so I would keep incrementally increasing until I got to 67,600. If you have a calculator that does have that square root button, that's very easy to figure out. Where did I get 264? Did I mean 252? I did. I totally made up 264 in my brain for some reason, and it should have been 252, which is why I got the wrong answer the first time. But that's a great, great, great image for you to realize that I make mistakes, but then I showed you how to recover from that mistake and not waste a bunch of time on that problem. Just because I got the wrong answer didn't mean I was going to give up. It meant that I was going to look at that problem and see, can I find my error very quickly? I was able to find my error very quickly, so I was able to recover. Sometimes you can't do that, and that's okay. You can flag that problem, move on, and come back to it. All right, let's move on to problem 3. Amelia wants to build a frame for a painting that she created. She wants to make the frame a 2-inch wood frame all the way around the painting. If her painting is 3 feet by 5 feet and wood costs $2.75 per square inch, how much will the frame cost? This is a really heavy problem. There's a lot to it, and these are the kinds of problems I get requested all the time. Let's go ahead and draw a picture of this to see what we're really looking at. So if I have a painting, bear with me, I am not an artist. I like math. I'm not a great artist, so we're just gonna go for it. I have a painting here. Da, 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 da. And we're gonna draw the sky, and we're gonna draw the grass, and we're gonna draw a friend. Okay, there's my painting. And she wants to make a frame around it. I'm gonna make it a wood frame. So here's my frame. Okay, if her painting is 3 feet by 5 feet, so that means that this value down here is 3 feet. No, we're gonna call that one 5 because it's longer. 5 feet, and this value is 3 feet. And they told us that wood costs $2.75 per square inch. The first thing I immediately realized is that the wood is in square inches, but my painting is currently in feet. Problem, because my measurements are not the same. So I have to convert one or the other. I have to convert my wood into cost per foot, which would be really obnoxious, or I can convert my painting into inches. I'm going to do that. So I know that 1 foot equals 12 inches. So that said, I know that 3 feet is going to equal blank inches, and I know that 5 feet is going to equal blank inches. Well, how do I know if I'm multiplying or dividing by 12? Because I'm going to use my conversion factor to help me. So if I'm going from feet to inches, from feet to inches, then I'm going to go from feet to inches. How do I get from 1 to 12? Did I multiply the 1 by something, or did I divide the 1 by something? I multiplied the 1 by something. I multiplied the 1 times 12. So then I'm going to multiply everything else in my conversion by that same value. If we were going the other way, if we were going from inches to feet, then I would go ahead and I would flip that. I see that you're saying that there's no volume. Is anybody else having that problem? Please comment below so that I know if it's a me error or if I know that it's a user error where we can like kind of coach you through how to get volume. So please let me know in the comments. Can you hear me solving this painting problem? Somebody let me know. I'm going to keep going until I hear from somebody. So I'm multiplying everything by 12. So I'm going to do 3 times 12. Now, if you're not confident with that, use your calculator. 3 times 12 equals 36. So I have 36 inches. 5 times 12 equals 60. Okay, I'm going to comment below to make sure that anybody else can hear me. Is anyone else having volume issues? All right. So now I've converted my measurements into inches. So instead of 5 feet, this is actually 60 inches. And instead of 3 feet, this is actually 36 inches. So now that I have my painting dimensions, now I can convert, well, I already converted. Now I can figure out my frame dimensions so that I can figure out my cost per foot. Now, obviously this problem would not take me this long on the actual exam. I'm over explaining everything so that everybody here knows how I'm explaining this problem. So, what is the length of this entire side of the frame? What is the length of that entire side of the frame? I know a lot of people would say 60, and I know a lot of people would say 62, but both of those are incorrect. They said that the frame is 2 inches all the way around. So that means that this distance is 2, this distance is 2, this distance is 2, and this distance is 2. So if the painting from here to here is 60, I still need to add 2 inches to this side and 2 inches to this side, which means my whole value is going to be 64. Now, what is the other side going to be? Taking that information and knowing that. If this length is 36, what is this entire length? 40, because I have to add 2 to the top and the bottom because the frame goes all the way around. So now, how do we figure out the cost per square inch? Well, we need to figure out the area of this frame, but not of the picture. We need to figure out the area of the frame and not the picture. So how do I do that? Well, I could cut my frame into a bunch of little rectangles, and I could find the area of each of those little rectangles and solve, or I can find the area of the entire brown rectangle and then subtract out the painting, which would be the blue rectangle, and then that would leave me with just the dark brown area. So I'm going to find the area of the entire brown rectangle, and then I'm going to subtract the area of the blue rectangle, and it'll give me the area of the frame. So the area of the brown rectangle is going to be 64 times 40, and the area of the blue rectangle is going to be 36 times 60. So if I solve that with my calculator, 36 times 60, that gives me 2,160. And if I do 64 times 40, that gives me 2,560. So now I'm going to subtract those two values to get the area of the frame. 2,560 minus 2,160 equals the area of my frame, which is 400. Then what am I going to do? Because that's not the answer to our problem yet. That's just the area of the frame. But they wanted us to find the cost of the frame. So if this is the area of the frame in inches squared, I'm going to multiply the 400 times $2.75, and that's going to give me the cost. So that said, 400 times $2.75 gives me $1,100, which is my cost. Where did I get the 64 and the 60 from? Thank you, Joseph, for answering that. Yes. So I took the dimensions of the painting, which is 5 feet and 3 feet, and I converted it into inches up here. By converting it into inches, I was able to get the 36 and the 60. And the 40, I had to add in that measurement of the frame. So I added in that extra 2 inches on both sides to get the measurement of the frame. This will also be on YouTube. So if you missed my explanation of that, I heavily explained it during that explanation. You can always go back and watch it. Yes, the frame goes all the way around. All right. Yes, Hope. I totally messed that problem up. So thank you for correcting me on the 260 for the hypotenuse. I just saw your comment for that. All right, let's go ahead and move on to problem 4. The table below shows Jason's weekly science test scores from a 5-week time frame. If he scored a 78 on his science test for week 6 and an 82 on his science test for week 7, what will the change be from the 6-week mean to the 7-week mean? All right, this is a complicated problem. I'm going to start with what I know. I know that they told us week 6 and week 7. So you know what I'm going to do? I'm going to add that to my table. So it says he scored a 78 for week 6 and an 82 for week 7. So I'm just going to go and I'm going to add that information into my table. So for week 6, he scored a 78. And for week 7, he scored an 82. Now, that said, what are we going to do next? We're going to look at what they're asking us to do. So they asked us to find the change from the 6-week mean and the 7-week mean. What is the mean? If we don't know what the mean is, then we can't solve this problem. So we've got different measures of central tendency. So the measures of central tendency are what tell us how the data is performing or what the data looks like. So the different measures of central tendency that we have measures, again, would I think about all this while I'm solving this problem on the test? No, but this is a teaching opportunity. Measures of central tendency. The different measures of central tendency we have are mean, median, mode, and range. Now, mean is very mean. It makes you do a lot of work. So it's going to be the average of all of the tests. You add them all up and then you divide by the number that you have. The mean is very mean. It makes you do a lot of work. The median is the dead middle of your data. I think about the median in a road. It's the middle of the road. So the median is the middle of your data. The mode sounds like the word most. So it's the data point that appears the most times. It's not the data point that is the greatest. That is one thing that people often misinterpret, is they think it's the biggest number, but it's the number that appears the most times. And the range is the difference between the highest and lowest. Difference between highest and lowest. The 6, the 78, the 7, and the 82, I pulled straight from the problem. The problem told us that data. I plopped it right into the data point. So how do I find the mean? I add them all up and I divide by that number. So I need to find the mean for week 6, and I need to find the mean for week 7. So to find the mean for week 6, that means I'm going to add up all my test scores up until week 6. So I'm going to do 85 plus 71 plus 94, and I'm going to run out of room, plus 67 plus 88 plus 78. And I'm going to divide it by 6 because there are 6 different data points. I have 6 different numbers I'm adding together. So what does that equal? Well, I'm going to use my handy dandy calculator again. So I have 85 plus 71 plus 94 plus 67 plus 88 plus 78 equals 483 divided by 6 equals 80.5. I'm going to do the same process for week 7. I'm just going to include week 7 in there. So I'm going to include all of this. But then I'm also going to add the 82. And instead of dividing by 6, what am I going to divide by now? I'm going to divide by 7. So now I have 85 plus 71 plus 94 plus 67 plus 88 plus 78 plus 82 divided by 7. So that's 565 divided by 7 equals 80.7. So what is the change from 6 to 7? Not a whole lot. We only increased by 0.2. So when I look at my answer choices, A is the only logical answer because we did increase, but we only increased by the tiniest amount. The number one error is going to be people picking C because it looks very similar. They're so close, but they did increase by 0.2. Now, I should have put increased by 0.2 and decreased by 0.2. Why? Because there's only one right answer. We're going from week 6 to week 7. So that would be an increase, not a decrease, because we're not going from 7 to 6. If it said, what is the change from week 7 to week 6, then it would be a decrease, because then you would be going from here to here, not from here to here. All right, let's move on to problem 5. Before I solve this problem, I want you to think about things you want to see me solve in the upcoming weeks. What are you really struggling with that you're like, man, I really wish she would go over this kind of problem? And if you don't have anything, that's okay. Maybe you just really enjoy coming to these Wednesday night sessions because you like the variety. But if there's something that you really want to see, please let me know in the comment box, because it really helps me guide the conversation in the direction that you need me to go. Probability, love it. I will add that to my list of things. Add page. So concepts for upcoming week. Probability. Ironically, the last few problems that I have here are exactly probability problems. So I don't know if we'll get to them today, but I absolutely have some really good probability problems for us to go over. But I will definitely keep that on my list and make sure that I continue to go over problems like that. All right, problem number 5. The table below shows the bowling score of 5 students on a local high school bowling team. The score of 70 seems to be an outlier. Which of the measures of central tendency changes the most by dropping that 70 from the data set? So let's go back to here. I'm going to copy and paste kind of what I had written up at the top so that we remember what we talked about with measures of central tendency. So remember, mean is very mean. It makes you do a lot of work. Median is the middle, mode is the most, range is the difference. So let's take a look at the median, mode, and range. This is exactly how I would do this on the test. I'm going to look at my 3 easiest responses, and then I'm going to go from there. So what is my mode? Which data point is appearing the most times in this data set? 122. It appears 2 times. Everything else appears once. So my mode is 122. Now, what happens when I cut the 70 out? What happens, bowling, when my data is only 135, 122, I cut the 70 out, so 145 and 122. My mode is still the same. So in that case, my mode is not changing at all. All right. Now that could change if this was a different data set. If 70 was the mode and then the 70 disappeared and something else became the mode, that would totally change our game. So this is not a problem where once I solve this, you're like, all right, that's the answer every time I see this kind of problem. You have to look at every data set individually. So which of the measures of central tendency changes the most? It's not the mode. Range. I'm going to take my highest and my lowest and subtract them. So my highest is 145 minus 70. So 145 minus 70 equals 75. Now I'm going to do that for my data set without the 70. So now my highest is still 145, but my lowest data piece is 122. So when I subtract those, the difference is 23. That's a pretty big change, but we don't know if it's the biggest. We're looking for the most change. All right, what's the median of this first data set? Well, let's write them in order. 70, 122, 122, 135, 145. So the median or the middle is 122. What is the middle of the other data set? Well, 122, 122, 135, 145. The middle is between the 122 and the 135. Well, how do I find what is in between 122 and 135? Add them together and divide by 2. So I'm going to do 122 plus 135 divided by 2. And that's going to tell me what's in the middle of those 2 data pieces. So 122 plus 135 equals 257 divided by 2 equals 128.5. Is the difference between these bigger than the difference between these? Not at all. Now I have to do my mean. If this was a problem that was towards the end of my test and I was running out of time and I discovered that the range had that really big gap, 23 to 75, I would totally pick that answer and move on. Is that correct? I don't know. However, that's a really big gap. And if I was running out of time, I know it's not the mode, and I got a really big gap for the range, I'm going to guess and move on. That way I have the highest chance of at least getting a couple of points from this time constraint that I have. But right now, we don't have a time constraint. So I'm going to go ahead and solve for the mean. So the mean of the blue data, I'm going to add them all up and divide by 5. So 135 plus 122 plus 70 plus 145 plus 122 divided by 5 equals 118.8. I'm going to do the same thing for my other data. I'm going to add them all up and divide by 4. So 135 plus 122 plus 145 plus 122. I hit the equal button one too many times. I got to do it again. 135 plus 122 plus 145 plus 122 divided by 4 equals 131. The gap between that is 12.2. The gap between 75 and 23 is like 40 or 50 something. So range is going to have the biggest gap. And you see, I could have picked that answer early on and been 70% confident it was correct. And like I said, if you've got all the time in the world, enjoy solving this problem. But if you don't have all the time in the world, use your time wisely and find that gap and take a good guess. All right, let's solve problem number 6. Not an easy problem, but a good old numerical solving problem. If x equals 4.7, what is the value of 3x plus 5 times the square root of x plus 11.3? So they gave us x, and all they want us to do is find this value. Now, this is a perfect example of a problem that could show up on anybody's test except for pre-K through 3. This could show up on anybody's test. That said, high school people, you would likely see it like this. Find f of 4.7 if f of x equals all of this. That means the same. Ooh, did not mean to do all that. That means the same thing as this. Function notation is so confusing for so many people. People don't realize that this and this are exactly the same. So let's go ahead and solve it. I'm going to take this x value and I'm going to plug it in or substitute the 4.7 in for the x. I'm going to take the x out of the game and I'm going to put the 4.7 into the game. So I have 3 times 4.7. I took the x out, I substituted in the 4.7 plus 5 square roots of 4.7 plus 11.3. Now, some of you might be saying, how do you know that square root goes all the way across? Because even though the computer didn't understand to pull the square root all the way across, the parentheses tell me that the square root is going all the way across. The parentheses are telling me take the square root of anything inside that parenthesis. So I have 3 times 4.7 plus 5 square roots of something. I'm going to add 11.3 plus 4.7, and I get 16. I'm going to continue to solve that square root. So I have 3 times 4.7 plus 5 times the square root of 16. What is the square root of 16? What does a square root even mean? A square root, when we are square rooting a number, we're looking for something times itself to equal that number. So I know 4 times 4 is 16. So I know the square root of 16 equals the value of 4. So 5 times 4. Now I've got 2 multiplication problems, and I know that in the order of operations, I'm going to solve multiplication before I add. So I'm going to do 3 times 4.7, which equals 14.1, plus 20, because 5 times 4 is 20. 14.1 plus 20 is 34.1, so my answer is A. Excellent job. All right, we have time for one more problem. So let's go ahead. Let's go ahead and do this problem. This is a good one. And then we'll save the rest for next week. So I promise I will get to those probability problems next week. All right. The sum of 2 consecutive even integers is 50. What is the value of the square root of the smaller integer? All right, so this is a problem that trips people up all the time, but it's really not that hard. The sum, the answer to an addition problem is 50. What am I adding? I'm adding 2 consecutive even integers, which means I'm adding 2 numbers back to back that are even, and it has to equal 50. So it could be 2 plus 4. It could be 4 plus 6. It could be 6 plus 8. And we could go on and on and on forever. It can't be 6 plus 10 because those are not consecutive. They're not back to back. And it also can't be 6 plus 7 because those are not back to back even integers. Those are 2 consecutive integers, not 2 consecutive even integers. So that said, I know that 25 plus 25 is 50. So I know that my 2 consecutive integers are going to have to be in the 20s. So 22 plus 24, let's start there. That equals 46, not enough. 24 plus 26, what does that equal? That equals 50. So I've found my 2 consecutive even integers pretty quickly. And then it says, what is the value of the square root of the smaller integer? Well, which one of these is my smaller integer, 24 or 26? 24. So the square root of 24 is what we're looking for. But I see that's not an option. But the square root of 26 is an option. Don't think you're wrong because this is not there. Just because the square root of 26 is there doesn't mean you're wrong. The square root of 26 is there to trick you. The square root of 24 isn't there because it's not simplified. I know that the square root of 24 is the same thing as the square root of 4 times the square root of 6. Well, what is the square root of 4? 2. So my answer is B. You might have also been taught to do a factor tree and to find partners. Well, you're finding partners because really all that is the square root of 4. So I'm going to pull that 2 out, and I get 2 square roots of 6. Therefore, B is the right answer. What's the difference between consecutive odd and consecutive even? Consecutive odd would be like 1 and 3, or 3 and 5, or 5 and 7, or 7 and 9, or 9 and 11, or 11 and 13. Those are all consecutive odd integers because they're back to back, but they're odd. Where did I get 2 plus 4? These were all just examples of the sum of consecutive even integers. So I was just giving some examples. All right, we have run out of time for today. If you have any more questions, please drop them in the comment box, and I will absolutely answer those questions for you the best I can. Milagros, I also saw that you were asking about that professional math test. I am not sure what you're referencing. So if you could tag me in one of our customer hub pages at Amy Sink or in one of our Facebook pages, I'd be more than happy to look that up for you, or I can answer that question for you next week, but I am not sure what you're asking. So you may have to clarify that question for me. Wouldn't have solved algebraically been faster? Joseph, excellent question. She asked if solving algebraically would have been faster. Honestly, for me, it wouldn't have been faster because in my head, I automatically knew that 25 plus 25 was 50. So I knew that 24 plus 26 was 50. However, solving algebraically, we would have identified that x is your smaller integer and that x plus 2 would be your larger integer because it's even numbers and there's 2 numbers in between an even number. It would have also been the same if we were doing odd. X plus 2 would have been your odd. So then I can do x plus 2 equals 50 and solve it that way. 2x plus 2 equals 50, subtract 2. 2x equals 48, x equals 24. That is absolutely a way you can solve it. And especially for those more complex examples of this, that would be easier. But again, I know that 25 plus 25 is 50, so I immediately knew 24 plus 26 was going to be 50. Excellent question. More consecutive integer problems. Absolutely. I will add that to my list. Consecutive integer problems. All right. If you have any other topics that you want to see, drop them in the comments. I will see you next week. I'm going to turn it back over to Dr. A for a quick closing message, and I will see you all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.